Now, writing a number x in a scientific notation which is less than 1. This is case 2. You should remember these points. Again, mark the reference position. As you know that the reference position means the first non-zero digit and next digit on the left. So again the same, count the number of digits between the original and the new decimal point. The new decimal point means the reference position. And now this is very important. Note the number which is negative. If we count the number of digits in the case of less than 1, so we take it power of 10 as a negative. So write the number of digits as the power of 10 and it must be a negative one. So look at this is question 1 part 3, given 0.00000039. So look at this is less than 1. So now required is scientific notation. The first of all, the reference position. So the reference position is between 3 and 9 because all the other digits are 0 and 3 is the first non-zero digit and 9 is the next on the left. So 3 and the reference position is between 3 and 9. So our reference position is between 3 and 9, and now this is our new position of decimal point. So we count the number of digits between the new decimal point and the original decimal point. So look at, if we count these digits, so that is 3 is the first one, then 2, 3, 4, 5, 6, 7. Now these are 7 digits between the reference position and the original position of decimal point, and as I told you, we take it as a negative. So our scientific notation of that number is 3.9 multiplied 10 power minus 7. Because this is less than 1, so we take the power of 10 as a negative. Look at another part, 0.00092. Required is scientific notation. Again, the reference position is between 9 and 2 because 9 is the first non-zero digit and 2 is the next on the left. So our reference position is between 9 and 2. So this is also our new position of decimal point. So if we count the number of digits between the new position of decimal point and the original position of decimal point, so these are 1, 2, 3 and 4. So these are 4 digits and we take it as a negative and a power of 10. So our scientific notation of this number is 9.2 multiplied 10 power minus 4. Now this number 0.0092 represent x, while 9.2 represent a. So it is between 1 and 10, and this minus 4 represent m, which is integer. Exercise 3.1, question 3. How long does it take the light to travel the earth from the sun? How much time? Mean the time is required. The sun is 9.3 multiplied 10 power 7 mile from the earth, and the light traveled 1.86 multiplied 10 power 5 mile per second. So we need to find how much time it will take. So from the question, the given data, so distance from the sun and earth, that is given that the sun is 9.3 multiplied 10 power 7 mile from the earth. So that is to represent distance, and distance is represented by s. So s equal 9.3 multiplied 10 power 7. Now, and the light travels, mean the speed. So 1.86 multiplied 10 power 5 mile per second. So it represents speed of light and it is represented by v. So in this case, v is equal to 1.86 multiplied 10 power 5 miles per second. And the required is how long does it take the light to travel the earth from the sun. So we need the time, that how much time it will take. So from equation solution, we know that we have an equation distance is equal to speed multiplied time. Distance represent s, while speed represent v and time represent t. So the time is required in this equation. So replace s by 9.3 multiplied 10 power 7 equal speed v replaced by 1.86 multiplied 10 power 5 or into t. So we need t, so divided both sides by 1.86 multiplied 10 power 5. So from here that's cancel and that become t equal 9.3 multiplied 10 power 7 divided by 1.86 multiplied 10 power 5. So when we divide 9.3 divided by 1.86, so it's equal 5, and multiply, and look at they have the same base. So if they have the same base, so quotient form, so if we take one base from that and the exponent are subtracted, so 7 when it's come in numerator, so its power become negative and they have the same base, so that becomes 7 minus 5. So 5 multiplied 10 power 7 minus 5. 7 minus 5 equal 2. So 5 multiplied 10 power 2. 10 power 2 means 10 square. 10 square equal 100. And 100 multiplied 5, that is equal to 500. So time is equal to 500 seconds. So now converting this time into minutes, and you know that 1 second is equal to over 1 by 60 minutes. Or 60 minutes is equal to 1 minute is equal to 60 seconds. So 1 second is equal to 1 divided by 60 minutes. So convert this into minutes. So divided by 60. So 500 divided by 60 minutes. So by cancellation we get 25 divided by 3 minutes. 25 by 3, when we divide this, this is equal to 8 whole 1 by 3 minutes. So it means that 8 minutes multiply 1 over 3. Now this 1 over 3 minutes, if we want to convert this again in how to convert a number from scientific notation to standard form. Now if the number is given in a scientific form or a scientific notation, then how we convert into its standard form? There are two cases. If the power of 10 is positive, so we move the decimal point to the right. For example, this is a question 4.1 multiplied 10 power 6, so that is scientific notation, and we want to convert this into standard form. Mean to remove this power of 10. So here the power of 10 is positive. So we move the decimal point to the right. So here given is 4.1 multiplied 10 power 6. So we see the power is positive, which is equal to 7. So we move the decimal point 6 places to the right. So 4 which is the reference position. So from here we move the decimal point 6 places to the right. 1, 2, 3, 4, 5 and 6, and then we put point. So that is the standard form. Remember that while moving the decimal point, extra zeros can be placed if necessary. So here we place extra 0 because we need to write this number in a standard form. So again, if the power of 10 is positive, so we move the decimal point to the right. And if there is needed extra 0, so we can place these zeros. So 4.1, this is the reference position. So from here we move the point 6 places to the right. So 1, 2, 3, 4, 5 and 6, and we put points. So that is the standard form of 4.1 multiplied 10 power 6. The case if the power of 10 is negative, we move the decimal point to the left. Now if the power is negative, the 10 power, then we move the decimal point to the left. This is question number 2, part number 1. 8.3 multiplied 10 power minus 5. We write this into standard form. This is given in a scientific notation. So we convert this into standard form. So here we see the exponent is negative, which is minus 5. So we will move the decimal point 5 places to the left. So 8.3, that is our reference position. So now we move the decimal point on left side, 5 places to the left side. So first, second, third, fourth, fifth, and we put point. So 0.000083 is the standard form of 8.3 multiplied 10 power minus 5. So these are two conditions, and you should remember these points. So if the power of 10 is positive, so you move the decimal point to the right. If the power of 10 is negative, you move the decimal point to the left.